Welcome back to the TechMoto channel and our series of videos on how to use an Arduino. So today we're going to talk about something quite fun actually, servos and how to attach servos to your Arduino. A servo is basically a motor that you can position. So you can program it to go into whatever position you like. It's incredibly precise. Great fun for robotics projects, or if you've got little doors that need to open up or something like that. But very, very, very simple to use. So you've got three cables that come out of the servo. And the important thing to say is here that these cables could be different colours. So you might end up with red and black and white, or you might end up with red and brown and yellow. But the rule of thumb is that, there's usually a red, which is your positive line. There'll be a brown or a black or a blue, which will be your negative line. And there'll be another colour. And the other colour will be orange or white or yellow, which is your signal cable. Now, most servos only turn 180 degrees, but you can buy servos that will turn 360. But they just turn like this. So you get these little sort of servo arms that you clip onto the top, and you can put a little screw into the top there to hold them in place. And they'll just turn to whatever position you like. Now, inside the servo, there is a little tiny DC motor. That DC motor is attached to a gear train, which gives it a little bit of power in these cheap and cheerful motors. But you can buy really hefty servos that will lift some pretty heavy weights. Inside there's a circuit board that controls the position of the spindle, dependent on how you program it. But what we're going to do is we're going to hook it up to our Arduino, we're going to jump into the Arduino IDE, and we're going to program it. So, as I said, you have three cables that come out of the servo. Mine are red, brown, and orange. So red is going to be my positive, brown is going to be my negative, and the orange is going to be my signal wire. And as I say, they might be slightly different colours, but it should be fairly easy to see which is which. Now, the servo comes with a female plug on it. To plug that into your Arduino, you can just use jumper cables. So I'm going to take a blue wire and plug it into my negative so that I know exactly which one's which. I'm going to take an orange wire and plug that into my positive, or the red one on this side. And I'm going to take a yellow wire and I'm going to plug that into my signal wire, which is actually orange on this side. But I now have yellow, orange and blue, and I have male connectors that I can plug straight into my Arduino. So the first thing your servo needs is power. So we're going to take our negative line, whatever colour that might be that you've used, to GND. We're going to take our positive line, and I'm going to take that to 5V. And then I'm going to take my signal wire and I'm going to take it to one of my digital inputs. So I'm going to use input 2. Now, that's it. That's all you have to do to hook up a servo to an Arduino. So let's move to the programming language and I'll show you how to make it move. Okay, so here we are in the Arduino IDE. Now we could go to the examples and we could go to servo down here, and there are two examples here, but we're not going to go into those just yet because they're slightly more complex, and I just want to start off very simple. So we've got our standard program template here, and the first thing we need to do is tell the program that we're going to be using a servo, and we need to include a library. And how we do that is we say hash include, and you'll notice that the word include goes green, and then we're going to have a bracket, and then the word servo, and pay close attention to the fact that I used a capital S there, and then .h, and then close those brackets. So that's basically telling our program that we need to use the library for servo control. Next thing to do is type in servo, and again capital S, and you'll notice that when I type that in it goes red, and then we just need to give our servo a name, and just as it was in similar videos, this name could be anything you like, but I'm going to call it my servo. Really important again in Arduino to put that little semicolon there at the end of that line of code. Now in your void setup, we need to set up our servo. So we say my servo, which is the name that I gave it, dot attach, and then we tell it what pin we've attached it to. Now we attached it to pin 2, so we have brackets either side of that, and then don't forget that semicolon. So we've told it that we're using the servo library, we've told it the name of our servo, and then down here we've said where our servo is attached on our I/O ports. Okay, so the next thing to do is to write a piece of code for our servo. And the simplest piece of code you can write for a servo is just to tell it to move to a certain position. And this is a really good idea because when you're putting your servo arm on, you want to make sure you get your arm in the right position. So we just say my servo, or whatever name you gave it, dot write. Now notice that write goes red because it's a recognized command. Open bracket, and then we just give it a position. So this is in degrees. So I'm going to say go to 0 degrees, close bracket, and then semicolon. Now that's it. That's your first program. So if we verify that, save the sketch. Let's hope that it verifies that. See down in the bottom right hand corner it's thinking about it. Okay, it's all good. So then we're going to send it to our circuit board and see what happens. Click the button. Okay, so the servo moves to position 0. So now what you want to do is, you know that's in position 0, so you can pull off your arm and you can put your arm back on the servo so that it's pointing in line with the servo or wherever you want it to be. Now if we come back into our programming language and we change that to 90 degrees and we verify that and we hit send, it'll flash on the Arduino and the servo will move to a 90-degree position. Now you can keep doing that, so let's take that to 120 and send that through. Moves to 120 degrees. So in theory, if I put that to 180, it should go back to the starting point, but just be the other way around. So it's uploading and it's gone back to the starting point. So now what you can do is you can put in other pieces of code. So I can say delay 1 second, and then we'll just cut and paste this because that's a lot easier. Paste that in and we'll put that to 0, and then we will put a delay of 1 second in there. So it's going to go to 180, it's going to wait 1 second, it'll go to 0, it'll wait 1 second, and then because this is a loop, it'll go back to the beginning and it'll do the same thing again. So let's send that to the circuit and see what happens. So you can see it's moving from 0 to 180, it's waiting a second in between. So now if you were to add in switches and lights and all sorts of other things, you could actually very easily make a door open, or you could make an arm move, or you could, well, I mean, literally your imagination is the only thing holding you back. But it's quite exciting. Okay, so that's a simple piece of code for a servo, but what happens if you want to make it go slightly faster or slightly slower? Well, that's where we come into the examples. So we go to File, Examples, come down to Servo, and we'll go for sweep. And let's just make that slightly bigger so you can see it on the whole screen. You'll notice they've done the same thing, so they've included the library of servo, they've called their servo exactly the same name as I did, and then they've said the initial position of the servo is 0, so that's just storing the servo position. They're saying their servo is attached to pin 9, well mine is attached to pin 2, so I'm just going to change that, and then they come into their main program. Now, remember that this main program is a loop, so it's going to do everything over and over and over again. But what they've done here is they've put a second loop within a loop. So they've put a for loop in here. So for position 0 to 180, so it will continue to loop this until it gets to position 180, or 180 degrees. It's asking it to increase by 1 degree every cycle. So every time it goes round this loop, it's going to increase by 1 degree. It writes the position. So it's going to start off position 0, add 1. So we're now on 1 degree. It's going to write pos. So pos is here. So it's going to say write 1. Wait a little bit of time. Then it's going to come back up here and we're on 1. So it's going to add 1, which makes it 2. Servo write 2. Wait. Come back up here. Add 1, so that makes it 3, servo write 3, wait for a fraction of a second. And it will continue doing that in this for loop until it gets to 180, and then it will move onto the second section of the program. Now in the second section of the program, it starts in position 180, and it's minusing a degree each time. So it's going to start off on 180, minus a degree, so 179, write 179, wait a fraction of a second. Come back up here, take off a degree, write 178, wait a fraction of a second, and so on until it gets to position 0. Once it gets to position 0, it gets to the end of its program, and it comes back up here in the main loop and it starts again. So if we bring up our circuit again, you'll notice that it's still doing it 0 to 180 from the last program that we sent it. But what we're going to do is send this example directly to the servo. So it will load up, the Arduino will flash, and now you'll notice that the servo is moving at a slightly different pace. Now we can change that pace by changing this delay here. So let's change that delay to, let's say, 50, and we'll change this delay to 50, and we'll send that, and you'll notice that it will go slightly slower. So you can really get some amazing control of this servo in the same way as if we just make that 5 and we change that to 5 and we send that, it should go slightly faster. So we'll send the program to it. So now you can control your position and you can control your speed. Let's say we only wanted it to go to 90. We can change it so that that for loop is 0 to 90. But down here, we would need to change the start point to 90. Because if you don't do that, when it finishes this section of code, it will finish on 90, but then this one would have started on 180, so you have to change that one as well. And if we send that off to the Arduino, you'll notice that now it'll do the same thing, but it only turns 90 degrees. Okay, so that's it for this one. Nice and simple. There are going to be future videos of how to control a servo with a potentiometer, but that will come later on. Bear in mind that the Arduino is only really powerful enough to power one servo. You might get away with 2 directly off the board, but if you wanted to run multiple servos, it's a good idea to have an external power supply. But we'll do that in a future video. So for now, thanks for watching. If you have any comments, please do throw them down below and I'll see if I can answer them. And I'll see you in the next one.